Hi, I'm Jill Burrows, and I'm here near the Sacramento area. The river behind me is called the American River right now, but it was once called Komsayu, and that means Roundhouse River. And that's likely from the fact that there would have been roundhouses all up and down this river because it was one of the main centers of the Nisenan civilization and the Maidu civilization in general. So, yeah, I can just imagine like all of the people living here in all of their their roundhouses, and it would just be amazing to see all the people here. Water is incredibly important to life, and I'm sure that you know that. If you go too long without drinking water, then you're going to die. Water is the first thing that we are born into. It's in our mother's wombs. Many Native people say that it's our first medicine. And it's true in more than one way, because we have, the water in the womb that we're born into as a single-celled organism that then multiplies and creates an entire human being. Then there's also the earth itself, which all of the waters on it created the first environment for life to come forward. And when all of that happened, we became attuned to living in this water. We can't leave this water. If we do, then we die. And the water, this thin layer of water on the planet is very, very thin. In fact, if you take a look at the entire radius of the Earth, and this includes everything up to the Kármán line, it's 6,471 kilometers. And of that, about 0.2% is the hydrosphere, which is the water that we require to survive. So if we go outside of that hydrosphere, either by going too far down where we can't get water somehow, or by going outside, we need to bring water with us in order to survive. That's why if you look at, every space explorer, if you look at the International Space Station, they had to come up with a way to make sure that they had all of their water, to make sure that they could recycle their water and continue to use it over and over again. Not too much unlike how water works here on Earth, right? You have rivers which flow from mountains where there's snowpacks. You have the water getting there by evaporating from the land through evapotranspiration, and then coming down wherever it falls. And that's roughly the water cycle. The places that you find water are, if you're walking on the planet, there's a lot of places. But let's say that you get into an airplane and you're taking a commercial flight. Well, by the time you reach cruising altitude, 99% of the world's water is below you. So one of the intriguing things is that even within that small, thin layer, there's not that much water. Most of the ocean is undrinkable. You'd have to evaporate it first to take the salt out of it, condense that water, and then you'd be able to drink it. And then also groundwater, if you go down deep enough, you end up hitting brackish water, which is the same sort of thing. It's a salty water. It might even have radioactivity in it. It's just, something that you wouldn't really be able to drink if you got to that point. And there are a lot of different ways that we interact with all of this water around us as human beings, and I don't think that we're entirely aware of every single way that we do it. So one of the ways that we do it is through carbon dioxide. So if you look at carbon dioxide and all of that what happens is that it does actually quite a few things. One is that the oceans absorb it, and when the oceans absorb it, that makes it more acidic. It turns it into a mild carbonic acid. And if you're familiar with that, that's essentially soda water, right? Maybe not as acidic as something like Coke, where they add phosphoric acid to it, but just regular, like soda water without anything in it. And what happens is that, scientists have actually been doing research in the past few years and have found out that clamshells get weaker, and they find out that the bones of fish get weaker. And all of this is because of that acidity that's being created within the ocean through all of the carbon dioxide that we've been releasing through our technosocial systems. And another way that that impacts the planet is through the temperature. So as the greenhouse gases rise, so does the temperature. And as that temperature rises, there's more evapotranspiration that occurs, which means that more water evaporates in one place and then more water falls in another place. And it generally ends up shifting the places that we see rainfall and where we see wetness and dryness. Another thing that happens is that as the glaciers melt, you'll end up seeing ocean levels rise, because what happens is that water from the glaciers ends up running through the ocean and forms a current that ends up pulling around the equator, so the planet gets a little bit fatter. And that actually ends up making it so that we have a more of a wobble in our planet as it's orbiting around the sun and as it's turning in day and night. Some of the other things that we do to impact water are reservoirs. So if you go up the stream, there's actually a reservoir there. I think it's the Nimbus Dam. And that is, it's partly responsible for increasing the water temperatures that we have in this river. But it's also responsible for keeping the water levels even right now, especially since we don't have as much precipitation as we could have these days. In fact, some of the mountain caps that we normally see entirely packed full of snow have actually entirely melted. And Native people have always known the importance of these ice packs and that they're the source of water, that they are essentially the breast of Mother Earth from which we drink milk. They're that important for us to be nourished, because without it, then the rivers dry up, and then we have no water, and then we die. Or we move to another place where there is water. But again, since we're a huge civilization now, we can't just up and move everything, because that would end up being, it'd be catastrophic, because we just go from destroying one ecosystem to the next. And that would be impossible to do, so we have to focus on mitigating things as we can. But I digress. Reservoirs are part of our technosocial systems. Some of them are used for power generation. So as there's increased evaporation from the evapotranspiration, and some regions become drier, then some of those dams that have been placed in those regions are going to end up becoming too low to sustain the power production of that hydropower facility. And we've actually seen this happen already. There's many dams that are much lower in their power output in recent years than they have been in the past. And then there's also, I think it's Lake Mead, where it's gone down to levels that had not been seen since the construction of the dam. And this is actually important on numerous different ways. Like one, you have all of this infrastructure that requires a lot of cooling. And even though they take in a lot of water and they release a lot of water out into the environment, they don't necessarily have the ability to keep running if those water supplies get too low. So for instance, if there's a data center in a desert somewhere and it requires piping in water from some reservoir, then that data center will no longer be able to operate at the same level because it won't be able to cool down its computers. Even though it's going to pull in all of that water and release all of that water somewhere. Well, except for some of the water. Some of the water is lost to evaporation. There's also issues around irrigation. For instance, some places are very naturally wet, and so they end up getting enough rain, and they're pretty good at maintaining an environment that works. You don't have to draw too much water for irrigation. But irrigation is actually one of the largest water draws that we have as a civilization. A lot of that water just goes out of a well into the ground, and then a lot of it just evaporates through evapotranspiration. And so, as the climate shifts, some places are going to require a whole lot more water draw in order to put that into the ground, where it also will just evaporate from it because of the increased temperatures during certain times of the year. And that is going to end up, putting a strain on all the other systems that also depend on that. Like I mentioned, the power systems before, those will also require, essentially competition with the irrigation systems that feed us. There's so much more that I could go into detail about all of this stuff and how it's all interconnected. Like dams actually break up the riverine ecosystems, just like roads break up our land ecosystems. So that river connectivity is very important because you have, for instance, if you're in an area where there is salmon and you don't have as much salmon as there used to be, then all of the populations of other animals that relied on that diminish. All of the land in the surrounding area is no longer as fertilized as it used to be, because there'd be animals that eat that salmon, and obviously they go and they do their business all around the surrounding area. That fertilizes trees and fruits, and then birds eat those, and then that spreads the fertilizer even further away. And so as we diminish the nutrient quality of all of these systems, everything around the river starts to suffer. So there's other things that happen around impervious surfaces, where you have, like for instance, there's many different creeks, as they're still called, that have been lined with cement, and they flow through all of the various different neighborhoods now. And so they've been sort of re-engineered to not meander or drift so that we can have the layout of neighborhoods that we have. But since it's lined with concrete, none of that water really ends up getting absorbed. If there's any pollutants or anything, those end up getting washed with the water, and they still end up draining into this river right behind me. So that's another source of pollution. I think there's also a couple of sewer overflow outlets all along this river. And in recent years, we've even been having issues with increased bacteria in the river and getting warnings about all of that stuff. And more of these things are going to happen because of how we interact with the water and how we treat the water. and how much we've affected the climate through increased temperatures. The other thing is, like I mentioned, when you have these impervious surfaces, since water doesn't get absorbed into the environment as much, that does make the surrounding area dry. But also, if there's somehow like some very increased precipitation,
Now it's raining.
it makes it more likely that you're going to get a flash flood, because that water can't go into the ground. It has to travel along that channel until it gets to another body of water, like the river behind me. As many times before an impervious surface is put in, there is a land use change. So obviously it goes from a natural environment to an environment where people are living in or building things in some way or another. And with that, oftentimes a lot of trees end up getting ripped out, and a lot of land ends up being covered with asphalt or cement or some other kind of impervious surface. And, again, that means that less water can soak into that ground, and so there's less chance for groundwater to accumulate. And that is also very important, because here in California, there's these land subsidences that have been happening over the last few decades, where you can measure using like GPS or some other reference system where the land was at one point, and now it's a whole lot lower than it used to be, because all of that volume of water has been withdrawn, and now it's in the hydrosphere, evaporating and coming down as rain, but not accumulating within the groundwater as much as it should. And there's also other things like mining. When you have mining, oftentimes there's a lot of water usage that accompanies that. And sometimes, like if you go look in Nevada, there's a bunch of maps that you can look at and see the satellite images and see that there are these like large red ponds. And those ponds are essentially there in hopes that all of this waste will eventually dry out. But of course it rains and the water accumulates in there. And if it rains too much, then that dam holding that pond back can break, and then it can pollute the environment and actually pollute the water system, making less water available for everyone else. So there's lots of different ways that we interact with water that we're not always aware of, whether that's from taking a shower, from the water that we drink, to doing laundry and releasing microplastics in the environment through our clothes, to the tires that we use that have fine particles that rub off and end up entering the streams. And all of those things have an impact to everything living in the water. And I hope that when you really truly understand all of these connections, I hope that you go out and learn more about all of this, because water is life. And so, we're in a very intriguing point in our history, and we definitely need to do things that will improve our future, because if not, things are going to get really bad really quick. And things are already going to do that, but I'm not going to dwell too much on that, because I personally have a lot of hope. I think that we can turn this around.